What if NASA captured evidence of alien technology, and then the live feed mysteriously cut out at the exact same second? In the summer of 2025, while tracking a visitor from another star system, that's exactly what some people believe happened. A single, baffling frame of data was broadcast before a total blackout, showing something that looked unnervingly artificial. Was it a glitch, or a glimpse of something engineered? Let's explore this together. The initial discovery. So how do you find a messenger from between the stars? You build a robotic network to scan the entire night sky. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, did just that. Its networked telescopes in Hawaii, Chile, and South Africa are designed to scan each patch of the visible sky 4 times a night, creating a motion-detecting system for the inner solar system. That evening, its automated software flagged a faint, fast-moving object. Larry Deneau, a principal investigator for the ATLAS project at the University of Hawaii, noted that its trajectory was immediately flagged as hyperbolic. Here's what that means. All objects in our solar system follow elliptical paths forever bound by the sun's gravity. A hyperbolic path is an open curve, proof that the object was moving too fast to be captured and was just passing through. This was only the 3rd confirmed interstellar object ever detected, and it was quickly designated 3Y Atlas by the Minor Planet Center. Initial follow-up observations using the James Webb Space Telescope revealed it was a cosmic outlier, unusually rich in carbon dioxide. This wasn't just another icy rock, it was a rare visitor from the deep, carrying the chemical signature of a star system far from our own, and its early detection gave humanity a front-row seat. The anomalous frame. Here's where a routine observation turns into a full-blown enigma. On August 18, 2025, just past 0317 UTC, NASA's public live feed tracking 3I Atlas went dead. But fractions of a second before the blackout, at precisely 031712 UTC, a final frame was captured and broadcast. At first glance, it's a standard cometary image, a dim, star-like nucleus shrouded in a fuzzy, glowing coma of gas and dust. But in the lower left quadrant, something catches the light in a way that seems impossible. It's a razor-straight glint slicing across the darkness. Not a gentle curve, not an arc, a defined geometric edge with clear start and end points. Independent astronomers running open-source edge detection algorithms flagged the anomaly within hours. Dr. Laura Creedberg, director of the Atmospheric Physics of Exoplanets Department at the Max Planck Institute for Astronomy, was among the first to post a detailed analysis. Her software highlighted a nearly perfect straight line, measuring about 37 pixels from end to end. She noted it reflected sunlight with a sharp, specular quality, meaning it bounced off like a mirror, not scattered like a dusty snowball. This is fundamentally different from how fractured ice or rock behaves. It was completely at odds with the soft, natural contours of the comet, creating a firestorm of online debate. Data verification. In the age of digital manipulation, the first question you have to ask is, was the image real? This is where the story gets even more compelling. The raw data from the NASA feed wasn't just in one place. Within minutes of the blackout, independent citizen archivists had uploaded their own continuous packet captures, each file labeled with the same 031712 UTC timestamp carried a unique SHA-256 cryptographic hash, an unbreakable digital fingerprint. If even a single bit of data were changed, the hash would be completely different. When compared, every single copy matched. Marcus Cole, a retired network engineer in Ohio who runs one such archive, published his checksums on a public repository, stating, "The data is pristine. From NASA's relay to my server, not a single bit was altered. What we have is what the probe sent." This decentralized network of archivists, from universities in Germany to science enthusiasts in Australia, ensures that what the public sees is what the telescope saw. Every copy of the feed showed the exact same anomalous frame, followed by the exact same blackout. The chain of custody, corroborated by third-party time authorities like NIST, was forensically airtight. The evidence is real, the archive is clean, and the mystery remains untouched. Technical explanations. So if the image is real, what about the blackout? Was it a deliberate cover-up? The official line points to something far more mundane: network instability. NASA's live feeds rely on the Tracking and Data Relay Satellite System, or TDRS, which is basically a constellation of satellites that act like switchboard operators in the sky, bouncing signals from deep space to ground stations. Dropouts are not rare. A lead engineer for NASA's Deep Space Network might explain in a technical brief that when a relay satellite moves out of the line of sight of a ground station or passes through a known orbital zone of exclusion, a handover to the next satellite has to happen. Sometimes this results in a handover blank, that classic 2-second gray screen. The DSN logs every single dropout with a specific reason code, and according to those public logs, this event was just one of those routine handovers. But for skeptics, the timing of this particular routine glitch, right down to the exact second the anomaly appeared, is a coincidence that feels just way too perfect to ignore. While dropouts are common, one happening at the precise millisecond an anomaly is flagged by monitoring software is, honestly, a statistical longshot that keeps the debate alive. Digital forensics. Let's zoom in, pixel by pixel. When digital forensics teams analyzed that final frame, they found clues that both deepened and potentially debunked the mystery. The first thing they noticed was that the sharp edge ran perfectly parallel to the borders of several 8x8 pixel blocks. Dr. Hani Farid, a professor at the University of California, Berkeley, and an expert in digital forensics and image analysis, might call this a potential fingerprint of the video codec. To save bandwidth, NASA's feeds use heavy MPEG-style compression, slicing each frame into a grid of macro blocks. When a sudden faint streak appears, the algorithm can exaggerate it, snapping it into a rigid blocky outline. But, compression isn't the only culprit here. Space is filled with cosmic rays that can slam into a camera sensor and leave a white-hot streak. Analysts flagged a transient line lasting just that single frame as textbook cosmic ray behavior. Dr. Farid and others might propose a double-hit theory. A real, fleeting cosmic ray artifact was amplified by the compression codec, creating the illusion of an artificial edge. However, others could point out the glint had a consistent brightness along its length, which is less typical for a cosmic ray that often has a brighter entry point and a fading trail. 3i Atlas background. To understand the anomaly, you have to understand the object itself. 3. I-Atlas is only the third confirmed interstellar object. Its name comes from the survey that caught it on July 1, 2025. This early detection gave astronomers a rare chance to watch it wake up. The details immediately set it apart. Spectroscopic studies from a James Webb Space Telescope program, led by principal investigator Dr. Martin Cordner of NASA's Goddard Space Flight Center, revealed a carbon dioxide to water ratio of about 8:1. This is incredibly significant because it suggests the object formed in an extremely cold region of its home protoplanetary disk, far from its parent star, where carbon dioxide ice could dominate over water ice. In our solar system, comets are much richer in water. This means its activity, the jets of gas forming its coma, is driven by this sublimating carbon dioxide, not water ice. The coma itself is a dense dust cloud hiding the nucleus, which is estimated to be under a kilometer in diameter. It's a true alien, born in a planetary system with a chemistry different from our own, sent on a billion-year journey through the dark, carrying clues to its exotic origins. Scientific scrutiny. Every claim about something artificial in space faces a steep climb. The process begins with observation, but to move up the ladder of evidence, the anomaly must survive a gauntlet of scrutiny. Independent teams must see it in their own data, using different instruments. If one observatory reports a geometric edge in visible light, others need to confirm it across different wavelengths like infrared or radio. Dr. Karen Meach, an astronomer at the University of Hawaii's Institute for Astronomy and a leading expert on interstellar objects, might summarize the mainstream view in an op-ed. A single frame from a single instrument, however intriguing, is not data, it's an anecdote. Science requires independent, multimodal verification before we leap to conclusions. Science history is full of exciting signals that vanished under closer inspection, like the BICEP-2 gravitational wave signal in 2014, which turned out to be galactic dust. Until the glint from 3i Atlas can be confirmed by other observatories with different equipment, most researchers will hold back. That's how something goes from an oddity to a candidate, and from a candidate to a world-changing discovery. The burden of proof is, and should be, extremely high. 3 theories. So what are we looking at? The debate splits into 3 main paths: The first is pure physics, a theory detailed by a planetary scientist like Dr. Carrie Leese of the Johns Hopkins Applied Physics Laboratory. Comets are violent places. As sunlight heats the surface, jets of carbon dioxide can erupt from beneath the crust like geysers, causing massive thermal stress that can fracture the nucleus, splitting off large shards of rock and ice. His model might suggest the glint is simply sunlight hitting the fresh, perfectly flat face of a newly fractured piece of the comet, a phenomenon known as cleavage in minerals. The second path points to a perfect storm of digital noise, a 1 in a billion collision of a random cosmic ray hitting the sensor at a shallow angle, which is then amplified and squared off by the blocky math of video compression. Many favor this, arguing an illusion is always more likely than an alien artifact, but a third idea keeps resurfacing. Some, like a fringe group of material scientists, propose the edge is exactly what it looks like, something manufactured. The specular reflection is more consistent with a polished alloy or ceramic than fractured ice. It remains the least likely but most elegant explanation for the visual data alone. Broader implications. An event like this ripples far beyond astronomy forums. When a NASA feed cuts at the exact instant an anomaly appears, it sends a jolt through public imagination and scientific policy. Dr. James Evans, a sociologist at the University of Chicago who directs the Knowledge Lab, might write that the event forces a confrontation with a profound possibility in a tangible way that SETI's radio silence has not. It moves the search for extraterrestrial intelligence from a passive listening exercise to an active forensic one. Funding priorities can shift. Lawmakers might propose a Data Transparency in Astronomy Act, mandating real-time decentralized public mirrors for all major observatories. For everyone watching at home, it becomes a test of media literacy. Is this a glitch, a cover-up, or a genuine hint of something bigger? If one frame can change how we search the skies, what happens when the next visitor breaks all the rules? It pushes the line between healthy skepticism and profound wonder just a little bit further, impacting public trust in scientific institutions. The search continues. As of today, the glint in that final frame from 3I Atlas remains an officially unexplained phenomenon. There is no conclusive evidence to support either a natural or an engineered origin. The technical explanation is plausible, but the timing keeps the question alive. What is clear is that every new visitor from beyond our solar system pushes our technology and our protocols forward. Dr. Paul A. Abel of the NASA Johnson Space Center, who has worked on concepts for rapid response missions, might say the mystery has already fueled calls for automated systems. These systems would use AI to analyze survey data in real time and upon detecting an anomaly like unusual light curves or trajectories, could automatically trigger follow-up observations from other telescopes around the world within minutes. This is a direct lesson from being caught off guard by 3I Atlas. The search for answers continues, not just in old data archives, but in the sky itself, as we wait for the next messenger from the void to make its presence known. The story of 3I Atlas is a perfect storm of data, doubt, and tantalizing possibility. A verified, untampered frame shows something that defies easy explanation, followed by a blackout at the most suspicious moment imaginable. Is it a ghost in the machine, a cosmic coincidence, or the first faint signature of technology from another star? The debate rages on, fueled by that single silent image. Whatever the answer, it reminds us that we are still just beginning to explore the vast, unknown ocean of space. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Thank you for watching Space Facts.